for 4.6, what we're going to be doing is I'm going to be giving you two equations of parabolas, and we're just going to have to compare them. What's the same about them, what's different about them. So that's basically all we're going to be doing. We're going to be sketching them really quick for some of them, but for the most part, it's just going to be listing the comparisons. You have in your homework this exact same list. Does everybody see that on worksheet 6? You have your exact same list in your homework as you do right here. This is what we're going to be using to compare the different parabolas or the different functions, okay? So you don't have to write it in your notes, but what I do want you to do on your worksheet, we're going to be looking at all of these different things, so I'm going to read them to you first really quick. So for each example, we're going to have to basically pick from this list of 8 things, 9 things, and 8 things, and apply which one goes to which pair of equations. So it's kind of like matching, but more than one might apply to each problem. So I want us to look here and see which ones can never be written down at the same time. So for A, both parabolas open in the same direction. Okay. B, we're going to have to determine if they have the same line of symmetry, which means that which value is the same of the vertex. Which one is line of symmetry? That means X is the same. C, parabolas have the same vertex. B, both parabolas have maximums. E, both parabolas have minimums. Let's pause really there. If a parabola has a maximum, if both of them have a max, can both of them have a min? No, it has to be one or the other, right? So what I do is I put a little curly bracket right there just to kind of indicate that for those it has to be either one or the other. They're kind of grouped together. F, the parabolas have the same width. What term am I looking at when I'm looking at how wide or narrow it is? What? Width. Yeah, which one? A, B, or C? Remember in our equation? If we have ax squared plus bx plus c, or the other one is y equals a times x minus h squared plus k, which one determines how wide or narrow the parabola is? It's A. So you're looking at A here. Both parabolas have the same width. Parabola f of x is wider than g of x, or parabola g of x is wider than f of x. If f of x is wider, can g of x be wider? No. Can they be the same if f of x is wider? So for all three of these, it has to be one of the three. You can't have f, g, and h all listed as an answer. Do you guys see what I'm saying there? Okay. So for d and e, it has to be one or the other. F, G, and H has to be one of them. Okay, you can't pick all of them. So let's look at an example. Example 1. So your instructions are to, from this list that is in your homework packet, we need to choose everything that applies to these two equations. First one is f of x equals negative 2x squared minus 4. Next one is g of x equals negative 2x squared plus 4. So write those down really quick. Okay, so for each of my parabolas, I'm going to use f of x blue and g of x purple. For each one, there's a lot of information that we have to figure out, right? So for f of x, let's look at f of x first. I'm going to just write f of x equals, and I'm going to write the equation again. Let's rewrite f of x in terms of h and k in vertex form. So that's going to be x plus what? 0 squared minus 4. And then let's just start listing some information. Which direction is this parabola going to open? Up or down? Down, because of that negative. So this one is opening down, so I'm just going to sketch a little downward parabola just so I know that it's opening downwards. What is the line of symmetry? X equals 0. That X value right here. What's the vertex? 0 and -4. And does this one have a minimum or a maximum? Maximum. And then for that last part, the F, G, and H, we're comparing the width. So let's look at the width here. That's the A term. What is the A term on this parabola? -2. So is that wide or is that pretty narrow? It's narrow, right? So this is a narrow graph. That's all of our information for f of x. Let's look at g of x. So g of x equals, let's rewrite this, -2 times x plus 0 squared plus 4. And we're going to list the same information. Is this parabola opening up or down? No. Also down. What's the line of symmetry? X equals 0. Next thing we looked at was vertex. What's the vertex? 0. Positive or -4? Positive 4. Since this one's opening down, does it have a min or a max? Max. And is it a narrow or a wide parabola? It's also -2, so it's narrow. We listed all of the information. What I want you guys to do is go through that list, A through H, which letters apply to these two functions. Just list them out, whatever you think might apply, now that we listed all the information. Okay guys, does A apply? Both open in the same direction? Yes, they both open down. Does B apply? They have the same line of symmetry? Yes, they do. The line of symmetry was x equals 0 for both of them. Does C apply? They have the same vertex? No. One was 0, -4, and one was 0, +4. Does D apply? Both have maximums? Yes. And then F, G, and H, do they have the same width? Is f of x, the blue one, wider, or is g of x, the purple one, wider? F, they both have the same width. They both are narrow because A is -2 for both of them. So the ones that applied here are A, B, D, and F. That's all we have to do. Does that make sense? So basically, you're going to be finding this information for every single one, and then just picking what applies. Okay? So let's look at example 2 then. Example 2. F of x is -1/2 x minus 4 squared plus 3. Okay, so because I didn't have to add anything else for this one, I'm not going to rewrite it. I'm just going to write f of x, because I would really like to write these side by side. So, f of x, is that one opening up or down? Down. What is the line of symmetry? X equals Positive 4. What is the vertex? Positive 4, positive 3. Does this have a min or a max? A max, because it's opening down. And since A is negative 1/2, is that a wide or a narrow parabola? It's a wide parabola. Okay. So let's look at g of x. So this was my ideal. I just ran out of room up top. I really would like to have them listed side by side. G of x, is it opening up or down? It's a positive 2, so it's opening up. What's the line of symmetry? X equals what? Positive 4. What is the vertex? Vertex is positive 4, positive 3. Since this one's opening up, does it have a min or a max? Min. And because A is 2, does it open wide or is it narrow? It is narrow. Okay, let's look at what applies here. Does A apply? They open in the same direction. No, one is opening down and one is opening up. What about B? They have the same line of symmetry. Yes, they do. What about C? They have the same vertex. Same vertex? Yes, they do. Okay, D, both have maximums, true or false? False. E, both have minimums, true or false? Also false, so we're not going to pick either one this time. And then F, G, and H. Which one is wider here? F of x is wider, because this is a fraction and this one was not. So which one says F of x is wider? G. So we have 3 that apply in this case. Example 3. The revenue R, so capital R is revenue, made by selling widgets at price P, so P is the price, can be modeled by this equation. What I want you to write is write the equation, and then right next to it I want you to label that capital R is equal to revenue and P is equal to price. So you don't have to actually write this part as long as you write the equation and label revenue and price for me. Okay? Parts A and B I do want you to write because I want you to know what the question is. So part A, what price will maximize the revenue? B, what is the maximum revenue? So just list A right now. We're going to do part A first. Okay, so part A asks us, what price will maximize the company's revenue? What I think is going to help us here is to be able to graph or sketch the graph of what's going on. Okay, so first of all, the thing we have to realize is that these are not the variables we've been used to using, right? What has this one been typically, or this entire time? What variable? Did you say y? Yeah, this one is our y, and so all the p's are what? Our x's, okay? So if I were to sketch the graph, and we're just going to do a sketch right now, on my axis, would revenue be the y-axis or the x-axis? The y-axis, because it's y. So that means P is the x-axis. Okay, so just draw that right now. We're just going to draw the axis. We're going to do the work in a second. So part A asks me, what price will maximize the company's revenue? So I am looking for the x value of my vertex.
Doesn't it go like that?
Okay, so if I am looking for the maximum price, that's the x value of my vertex, because my vertex is always going to be my maximum or minimum point, right? So I'm looking for the point on my vertex, but I'm just asking for price, so I just want the x value. So basically, all we have to do to find the maximum price is find the x value of the vertex. How can I find the x value of the vertex? X equals, this is like your best friend, negative b over 2a. That's all we have to do. We're just looking for the vertex here. Whenever we're looking at these word problems, the vertex is really the most important point for us. That's what we're trying to find. Okay? So, negative b. What is b here? 100. So, negative 100 over 2 times negative 5. So that's going to give me negative 100 over negative 10. So my x value is positive 10. Now, this is a price, so it's actually positive 10 what? Dollars. So my maximum price is $10. Or that's going to maximize my profit. We're going to solve first, and then we're going to sketch that graph, and it should become really, really clear. Okay, part B. What is the maximum revenue? If P maximizes my price, how could I find the Y value for that? We want to plug 10 in for P and find R. So that's going to be negative 5 times 10 squared plus 100 times 10. So that's negative 5 times 100 plus 100 times 10. So that's negative 500 plus 1,000. So what would my maximum revenue be? $500. Okay. I actually want to sketch the graph so you guys can see what's going on, so you're not just following the procedure every single time. So let me give you a second to make sure everybody has everything written down, because I'm going to have to scooch this up a little. This is basically the same thing we've been doing. It's just an application problem. So my prices, let's count by ones here. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go up to 12. Okay. So my price we can count by ones. Now, revenue is actually growing a lot faster, so let's count by 100. So that's going to be 100, 200, 300, 400, 500, 600. I'm going to stop at 7. Okay, so we're actually just going to sketch this really quickly to show you what it is we're talking about. So what I'm looking for here is my vertex, or my maximum point. The maximum price was 10, and the revenue was 500. So let's graph that point. That's like right here. Okay, and then it was opening down because of the negative 5. So there we go. Okay, this is what I want you guys to think about. Remember when gas prices were really, really, really low, and so more people were at the gas station filling up because they were driving their cars around more? But then last week when gas prices went super, super high, have you seen a lot of people at the gas station?
Yeah.
Not as many, right, as when it was a little bit lower this summer? Because the price increased, and so less people are willing to pay for it. Or, do you guys remember when movie tickets weren't so expensive? You know how expensive it is to go to Edwards now? Did you go to the movies more when it was cheaper? Or did your parents give you money more often to go to the movies when it was cheaper? I know I did. I don't go to the movies ever anymore. So the price has gotten too high that I'm less willing to go. That's basically what this is saying. Here's my graph for selling widgets. When the price is lower, more people are willing to buy it, so I make more money. So this is my price axis. This axis is how much money I make. So when I'm selling at a lower price, more people buy and I make more money. As I gradually increase the price, I'm still making more money because it costs more, right? But there comes a point called your maximum point where people are willing, as many people as possible are willing to pay that price. But as it starts getting more expensive, less and less people buy, and so your revenue decreases, right? Okay? We are looking for this point. That is your vertex and your maximum point there. That's what we want. The question is asking, what price is going to maximize my revenue? At what price can I sell widgets that I'm going to make the most money? So what is that perfect market price? And then the part B asks us, okay, so when I'm selling them at that price, how much money am I going to make? So that's what it's asking you. Okay, so basically what you're looking for in all of these problems is the vertex, because that's your maximum point. That's the kind of like the magic point. Okay, so that movie ticket price where everybody was going to the movies because it was cheap enough, but the company was still making enough money. Or those gas prices where it was cheap enough to where people didn't feel bad going to pump gas, but the gas companies were still making, they still make zillions of dollars anyway, but it doesn't. You know what I'm saying? Okay, so that's what we're looking for. This is an application problem. This is economics. People actually do this. So you guys want to know where this applies in real life? This is real. This is a real problem that economics, what is it called?
Supply and demand.
It's supply and demand, but people who study economics, this is what they do, okay? There's people that this is their job, okay? So this is an application problem, how we can apply what we're doing to real life.